All right, hey gang. I know you guys are out with the choir thing this morning or today, so I hope all that goes well. I know that not WOSN 44 has been doing that for a long time, and I can remember I did that as well in high school. So I hope you guys have a great time and sing well, and we'll see you tomorrow hopefully. So what we're going to get into, I'm going to make this as quick and painless as possible, but I want to go ahead and show you right here, and I got to figure out which way I need to point this. Okay. What we're going to look at here is going to be what's called a coordinate proof. Okay. And let me get that a little sharper. No, not that one. There we go. With the coordinate proof, folks, we're basically looking at proving something using the coordinate plane, hence the name. But we're also using variables here, okay? Because if we can go ahead and plug in any number for the variables, then we can go ahead and say it will be true no matter where the location of those points will be, okay, as long as we have the original figure. So as I look at this, we're going to prove something called the triangle mid-segment theorem. Now, what is a mid-segment? Well, the mid-segment actually joins the midpoint, so I'm going to estimate this to be the midpoint here, and this to be the midpoint over here of two sides of a triangle, okay? And so if I go ahead and do that, if I go ahead and connect those two, there are two characteristics that we're going to find out are going to be true using this theorem. The first thing is that these lines are going to be parallel to each other, okay? And the second is that this length is going to be half the length of the non-intersected base, okay? So to get things started here, let's go ahead and identify what the midpoints of these two sides are going to be, okay? Now, if you remember, the midpoint formula, I'll write that over here, was x plus x. I could say 2 plus 1 over 2, and then y plus y over 2, okay? So we have that formula right there. Hopefully you can see that okay. So if I go ahead and do that, if I go to 2 plus 0, 2a plus 0 divided by 2, that gives me just a. So my x value for my coordinate here is just going to be a. If I do 4a plus 0, again the y plus y, 4a plus 0, that's 4a divided by 2 is 2a. So that point right there is the midpoint of that side. If I do this side over here, 4a plus 2a is 6a divided by 2 would be 3a. That's going to be that point there. And then 2a plus 4a is 6a divided by 2 is again 3a. Okay. Now, basically, folks, I made up these points so that they all had multiples of 2 in them, so that when we divided by 2 here, guys, we ended up getting whole numbers. You can get half A's, you know, a third A, but again, I wanted to make sure that we were getting something that was more user-friendly when we go to do these proofs here, okay? So in taking a look at those points, if I wanted to figure out if I wanted to prove that these lines were parallel, I'm going to say AC is parallel to, I'm going to make this point D and this point E, okay? If I wanted to go ahead and prove that those were parallel, I would use my slope formula. Now the slope formula is this right here, y2 minus y1 over x2 minus x1, okay? Now it's very important that when you do your coordinate proof that you show all of the work. The work is the proof, basically, okay? So as I look at this, I'm going to do that with A and C first of all. I'll put AC for the slope here. I'll do something like this, 2a plus 0. Sorry, it should be minus 0. We're subtracting here. 2a minus 0 over 4a minus 0. Okay. Now if I simplify that, it just becomes 2a over 4a. And if I reduce that down, the a's will go bye-bye, okay? They cancel each other out. 2 divided by 4 is 1/2, okay? So the slope of AC as of right now is 1/2. So if we do this correctly, we should see that the slope of DE is the exact same. And so as I look here, I'm going to do something like this. I'll do the y values first. 3a minus 2a. Okay, again, we've got the y values over there. okay, 3a minus 2a, again, y value, over 3a minus 1a. Okay, now 3a minus 2a is just a, and 3a minus a is 2a. Okay, now again, like the last one, we can cancel out the a's, and we are left with 1 over 2, which is the 1 right there. Okay, DE has a slope of 1/2. So what have we proven? Whenever you do a coordinate proof, make sure you put down a summary statement for the work you've already done. So I'm going to say something like this: AC is parallel to DE. Okay? All right, if you want to, you can use those 3 little dots. Therefore, right? Therefore, AC is parallel to DE. Okay? Now, the other proof is to prove this equation right here, which is that DE is half of AC. Remember, I said that mid-segment, going back here, this mid-segment is half the length of AC. So if I do that, I want to use our distance formula here. Now remember, our distance formula was this: x sub 2 minus x sub 1 squared, y sub 2 minus y sub 1 squared. Okay, so that's our distance formula. So if I work this out, let's do it with AC first. AC has the distance, and we're going to do 4a minus 0, and then 2a minus 0. Okay, now what that gives me is this. Dumb cord of mine is not very nice. Maybe I can move my computer over here. That's a little better. Okay. So if I work this out, let's see here, AC square root 4a minus 0 is just 4a. 2a minus 0 is just 2a. Now if we square both of those, we get this 16a squared. We're squaring both the 4 and the a. And squaring 2 and a, we get 4a squared. Okay? Now, if I bring those two together, you get 20a squared. Okay? Now, we can simplify this. Let's see here. Let me wait just 1 second. I think, yeah, well, let's just wait and see something here, because I'd have to teach you something that I haven't taught you already on simplifying radical expressions. So let's take a look at the next part. If I was to do the length of DE, okay, DE will be equal to this, okay. If we do the x values, 3a minus 2a, and then we have 3a minus, oh, hold on, that was the y value, sorry. Should have been just 3a minus a. There we go. And then the y value is 3a minus 2a. There you go. Okay. Now, for 3a minus a is 2a. 3a minus 2a is 1a. If I square both of those, you have 4a squared plus a squared. Which ends up being 5a squared. Okay. Now, as of right now, I just told you a moment ago that this is half the length of this. This doesn't look like it's half the length, does it? Okay. And I was curious if I was going to have to teach you this, but here it goes. If I was to simplify a square root, you guys should know by now the square root of 49 is 7, right? Okay. So what is the square root of 20? Okay. Well, the square root of 20 is not a perfect square, and so we have to simplify that radical expression, the square root expression. If I break it down into a perfect square and a non-perfect square, okay, what is the square root of 4? It comes out as just a 2. And so this expression right here is 2 square root 5, okay? Now, the other thing that we need to consider when we simplify these radical expressions is this. What is the square root of a squared? Okay. Well, let's consider this for just a moment. What's the square root of 9 squared? Well, the square root of 9 squared is the square root of 81, and the square root of 81 is just 9. So what am I trying to tell you? A square and a square root cancel each other out. So this is just a. Okay. So going back here to DE, what we have is this. We have just a. A is going to come out. Remember, the square and square root cancel each other out. It comes out just a square root 5. Okay. For AC, remember the square root of 20 becomes 2. If I look over here, 2 radical 5. So I'm going to put a 2 on the outside. The square root of a squared is just a. So now compare this. You have a radical 5, and then you have 2 a radical 5s. So how much bigger is AC than DE? We know that AC is twice the size of DE, or that DE is half the size of AC. So therefore, I am just proving that DE is 1/2 of AC. Okay? So we still want to take this and apply it. So let's go over here to the back side, and I've got a couple of pictures here. First of all, again, this is a mid-segment. It joins the midpoints of the two sides of the triangle. So these are going to be parallel. And I also know that this length here is half of this length here. So I could go ahead and do one of two equations here. I could go ahead and say 4x plus 8 is half of 23.5 plus 7x. Or I could go ahead and do, I could actually double both sides. I could go ahead and say this. If I was to double the mid-segment, that would equal the non-intersected segment. Okay? Do I care which one you do? I do not. They're both the same equations here. Okay? In fact, in this case, let's see here. Bring my handy-dandy calculator here. If I was to go ahead and distribute that 1/2, half of 23, 11.525, let's see here. If I do 23.5 divided by 2, 11.75 plus, and half of 7 is 3.5x. Okay? So if I go ahead and subtract 3.5x from both sides, I get 0.5x. If I subtract 8 from both sides, you get 3.75. And if I divide both sides by 0.5, 3.75 divided by 0.5, you get 7.5. Okay, so just showing you what that would have been if we would have solved that first equation. If we do the second equation, I get 8x plus 16 equals 23.5 plus 7x. If I subtract 7x from both sides, you get x. If I subtract 16 from both sides, you get 7.5. Okay? So, with that being said, the other thing that you should probably get in the habit of doing is plugging it back in. So if we take 4 times 7.5 and add in 8, you get 38 here for this length. Okay? If we did it correct, we should get 76 plus 7 times 7.5. And I get 76 there. So 76. So we are correct. Okay? So again, it's half the non-intersected segment there. Okay? So this last problem, there's actually a shortcut to this problem. It looks really busy. Here's what I want you to see before we even look at the given here. This point is the midpoint of that side, and so is this point here. Therefore, we know that this is a mid-segment. This line is parallel to this one, and it is half of this one. Okay? This point right here is also a mid-segment, or midpoint, so therefore this is a mid-segment. That makes this one parallel to this one. Okay, and it will also be half the length of that one. And then the last one is also going to be a mid-segment, so this one's also parallel to that one, and it is half that one there. Okay, now it says up here that the perimeter of the big triangle ABC is 32 centimeters. What's the measure of n? You can do one of two equations here. You could go ahead and say this: since the perimeter of this big triangle is 16, and each of these mid-segments is half of the segment it's non-intersected with, then the perimeter of this smaller triangle would have to be 16. So I could do this equation, n plus 1/2 n plus 7/8 n is equal to 16, okay? Now, there's a lot of fractions there, and so you can choose that one, or you could go ahead and do this. If this is n and it's half the non-intersected segment length, then this whole length right here is going to be twice that, okay? If this is half n, then this non-intersected segment is going to be just n. And then this one, if we double 7/8, we get 14/8, which would be 1 6/8 or 1 3/4. So this would be 1 3/4 n, okay? So in the end, if I add up all the n's here, I could also have the equation n plus 2n plus 1 3/4 n is equal to 32, okay? All right, both those equations will work out to be the exact same thing, okay? So, with that being said, let's go ahead and solve this first one first. I'm going to make this one actually 4/8. 1/2 goes to 4/8. And so this would be 4/8 plus 7/8 will make 11/8. 1 and 11/8. 11/8 is actually 1 3/8, so we have 2 3/8. N equals 16. Okay, now I'm going to double check that with my handy dandy calculator here. 1 plus 1 ABC2 plus 7 ABC8. Okay, 2 3/8. We're good. Okay, so now I'm going to take 16 and divide by that. 16 divided by the answer, second answer, and we got 6 14/19. Now, if you didn't get a fraction there on that, let's see here. This is going to be approximately 14 divided by 19 is 0.7. So it's about 6.7 is what n is going to end up being there. Okay. Now over here, if I add these up, 2, 3, 4, 4 3/4 n equals 32. Okay. So if I go ahead and take 32 and divide it by 4 ABC 4, 4 3/4, we get 6 14/19. Okay. Oop, not 14, 6 14/19. Approximately 6.7. Okay. So again, I'm giving you some options there. The key here, and I know that was kind of a busy picture there. I hope that it didn't cloud your understanding of the fact that the mid-segment is half of the non-intersected segment, and it's also parallel to it. Okay. Again, going back to the emphasis here, you can do a coordinate proof to prove things as well, if you prefer the algebra there. Okay. So with that being said, I want you to take a look at Schoology here, folks. Okay, take a look at the Schoology. If there's anything that needs to be done for tomorrow, it'll be posted. Actually, I think I had you do parts of the Chapter 4 review. So have those parts done for tomorrow, okay? Actually, I think we'll take a look at them on Thursday. So, again, I hope that you had a great time while you were at the 44 and sang well, and yeah, some good times. Anyways, we'll talk to you later. Bye.